is the summer of 1843 in a Manchester brewery. A 25-year-old experimentalist is dropping a paddle wheel through warm water and recording the temperature rise to 4 decimal places. The conclusion he will publish is that mechanical work and heat are convertible at a fixed exchange rate, and the discovery will become the first law of thermodynamics. Tonight, we cover the conservation of energy. Joining me are a theoretical physicist and an experimental physicist.
The principle of conservation of energy states that the total energy of any isolated physical system remains constant over time. Energy may change form: kinetic, gravitational potential, elastic, thermal, chemical, nuclear, electromagnetic radiation, mass energy via E equals m², but the total never increases and never decreases.
The original experimental discovery came from a careful precision calorimetry program. The Manchester experimentalist used a paddle wheel driven by a falling weight to mechanically heat a tank of water, measured the temperature rise to 4 decimal places, and calculated the exact ratio between work done and heat produced. The mechanical of heat is approximately 4.184 joules per calorie. His result, published in 1845, established that work and heat are convertible forms of the same underlying conserved quantity. The conversion constant is now known as the joule.
The deeper origin of energy conservation was uncovered in 1918. A German mathematician proved a remarkable theorem connecting symmetries to conservation laws. Every continuous symmetry of the laws of physics corresponds to a conserved quantity. Conservation of energy emerges directly from time translation symmetry, the fact that the laws of physics are the same yesterday, today, and tomorrow. Conservation of momentum emerges from spatial translation symmetry. Conservation of angular momentum from rotational symmetry. Noether's theorem is one of the most beautiful results in all of theoretical physics.
In classical mechanics, energy conservation is verified to extraordinary precision. Pendulums oscillate forever between gravitational potential and kinetic energy with no net loss. Springs trade elastic potential and kinetic. Frictionless air track gliders in undergraduate teaching laboratories conserve total energy to within 0.1% over hundreds of collisions. Modern gravitational wave detectors measure energy conservation in colliding black hole mergers at the 17th decimal place of strain. The principle is among the most experimentally verified statements in all of physics.
Einstein extended energy conservation to relativistic systems in 1905. The famous formula E equals mc² states that mass itself is a form of energy, multiplied by the speed of light squared, an enormous conversion factor. 1 kilogram of matter contains roughly 25 billion kilowatt-hours of rest energy. Nuclear fission converts about 0.1% of the fuel mass into energy. Nuclear fusion converts about 0.7%. Antimatter annihilation converts 100%. Mass energy equivalence is the most explosive expression of energy conservation in nature.
There is one famous apparent exception. General relativity does not have a global conservation of energy in an expanding universe. The cosmic microwave background photons have been redshifting for 13.8 billion years, their wavelength stretching and their energy decreasing. Where does that energy go? It does not go anywhere. It simply is not conserved at the cosmological scale. Time translation symmetry is broken by the expanding spacetime metric itself. Noether's theorem still holds, but the symmetry it would invoke is absent.
The principle implies that perpetual motion is impossible. A perpetual motion machine of the first kind would produce more energy than it consumes, directly violating the first law. The United States and Trademark Office has refused to grant patents for perpetual motion devices since 1870. The European Patent Office rejects them on first review. Conservation of energy is not a hypothesis to be tested, but a foundational principle that filters which proposed physical theories can be considered at all. New physics must respect it or replace it.
3 takeaways. First, conservation of energy states the total energy of any isolated system remains constant. Formulated experimentally in the 1840s through paddle wheel calorimetry, the mechanical equivalent of heat is 4.184 joules per calorie. Second, Noether's theorem from 1918 shows energy conservation derives from time translation symmetry of the laws of physics. Einstein extended energy to include mass via E equals mc squared. Third, perpetual motion is forbidden. The principle is among the most experimentally verified in physics. Thank you, theorist. Thank you, experimentalist.